Hi there, this is our second video where I am going to teach you about how computers work in depth and how we can use programming languages to interact with the computers. So let's start with the first topic of today, which is how computers work. So most of you, or I think all of you, have at least know, at least seen what a computer is. This tablet is a computer, this phone is a computer, this laptop is a computer, your desktop is a computer. But what makes a computer? Let's understand the parts of a computer in detail. So basically a computer has three sections only. It is input output, next CPU, and the third and the final one is memory. Okay, so let's give an example, you will understand it better. Let's say there is a calculator. So calculator is also a type of computer. So let's say there is a calculator and we want to add two numbers. Let's say 2 plus 2. Okay, so you know the answer, right? 2 plus 2 is 4. Okay, so you take the calculator and you type 2 plus 2 equals. So what you are actually doing is you are giving some kind of data to the computer. You say, hey computer, take 2 and take another 2. Now add these two and give me the result. These are the instructions that you are giving to the computer. This is input, and you are giving the input through what? Giving the input through keypads on the calculator. So that's how you are giving the input. Now what the computer does the computer take the data and sit there? No, right? The computer takes the data, it first takes the first number. It sees, okay, so this is the first number. Okay, this is the first number, it's 2. Okay, what's the next number? Okay, let's see. Yeah, this is the second number, 2. So let's add them. It adds them, the result is 4. So this thing is processing. The computer actually does something. Computer does something with the data you just provided the computer. You provided the computer what? Add first number and second number, add 2 plus 2. Okay, the computer does the thing actually, and this is the thing called processing. Now the computer doesn't give you data immediately. Okay, doesn't give you data immediately. There's a it adds the thing. 2 plus 2 is 4. Now this 4, it keeps this thing somewhere into its own memory. This is the third section of the computer. This is the third section of the computer, which is memory. It adds both the numbers. The result is kept somewhere, some location in the memory, and finally it gives you the output that, hey, 2 plus 2 is 4, and you see the output. This is the output thing. So input, add 2 plus 2 and show me the result. Process, add two numbers, keep it somewhere. Memory, you keep the number in a particular location, and output is what you see, that is 4. So this is actually a cycle. This is called Ipo cycle, input process output cycle. And why is it so? So let's say I tell you, hey you, go make a tea, make a cup of tea. So this is the order that I give you. So my order is input for you. You then go to the kitchen, then do all those stuffs and make tea. You bring out milk, you put it and do all the required steps to complete a tea. So this is process. I give you input that make a cup of tea. You did the thing. It is process. And what is the output? You bring me the cup of tea. That's the output. So this is a input output, input process output cycle. Input process output. I tell you, okay, go to the shop and bring me these things. Okay, so this is the input. You go to the shop, you buy those things, you come back home and you give me those things. That is a process, and those things what I get in my hand is the output. And don't think that input can be given in only one terms in computers like keyboards and mouse. Okay, that's not the thing. Let's say Amazon Alexa or Google Assistant. You say, okay Google, do this. Open YouTube or open Netflix. So what is this? You are giving input to the computer through voice. It's a modern technology, and in machine learning or deep learning, all those stuffs, you give input through images. Computers visualize the image. It then learns, oh, this is a dog, okay, this is a cat. So what's the input here? The input is the image that the computer sees, that you give the computer. Computer understands it. Okay, the computer understands it. Okay, it is a animal. Okay, it is a human. It understands this is a process, and it finally tells you that, okay, so this particular thing is animal, or this particular thing is human. So this is what this is output. Okay, so next topic. What is a programming language? Before that, just tell me, what is a human language? English, French, German, Russian, Mandarin, Japanese, lots of them, Hindi, Bengali, lots of them. These are human languages. And what do you use human languages for? To interact with each other, okay? To interact with each other. Hey, how are you? You understand this, okay? But if I tell a computer, hey computer, how are you? Of course, if it is a AI, then it will understand. But let's say it's not AI. I just tell the computer, hi computer, add 2 plus 2. The computer won't understand us, right? Because let's say you are a German and you speak Chinese, you won't understand, right, what I say, because our language is not the same, right? And just like that, programming languages is a is a set of languages, and I use the word set because there are lots of languages out there. Just like in human languages, you have so many different languages like Hindi, English, German, French, Russian. Just like that, computers do have many types of languages like C, C++, Java, Python, Golang, and all those stuffs. Okay, so why do you use programming languages? Because computers do not understand human languages. Computers do not understand human language, and we humans, we need to interact with the computer. So how can we do that? We can use programming languages. It is the intermediate part which allows us to interact with the computer without actually knowing the language of computers, because computers do not understand Hindi, English, French, German, or anything. Computer only understands two things: on, off, and 1 is for on, 0 is for off. That's what a computer understands. So in computer, suppose English alphabet A, capital A, in computer is represented by, let's say, 010010, whatever. But you human cannot remember all those combinations, right? So you need some kind of intermediate language which you can speak, or at least which you can write, or which you can understand. So that's why programming languages come into existence. So there are actually three types, 3 generations or 4 generations of languages. So low level languages, middle level languages, and then comes high level languages. Python is a high level language. And why do we call it high level? Because there is a high level of abstraction, and by abstraction I mean you don't see a lot of things which are going on inside the computer, which is actually taking place inside the computer. Okay, you say, okay, there's a list of this 5, 10, 15, 30, 1, 2, 3. You want to sort this list in an ascending or descending order. Okay, you want this to grow from small to large, or from large to small. You just tell Python, okay, sort this, sort. It sorts. But inside the computer, it's working in a very different manner. There are algorithms going on, there are complex logic going on, then finally it comes on to hardware, then the hardware works in a very different way, and ultimately you get the result you wanted. But Python doesn't let us know all of this. So Python is a high level language. JavaScript, same goes for JavaScript, is a high level language. Why high level language? I'll come on to the details later when I tell you what is a compiled, what is interpreted, what is statically typed and dynamically typed. Okay, I'll come into these later. Now, what is middle level language? Middle level languages are like C++ or Java, like those. They are all, there is also abstraction, but less abstraction as compared to high level languages. And finally there comes low level languages. What are low level languages? C. bare bone language. It lets you interact with the computer hardware directly, not by any functions, these that, not like that. You can directly interact with the computer system, with the memory, with the processors, all those stuffs. Okay, and what are processes? I'll come into those later. So these are the language. You can also see these you know what are those called, assembly languages. These are low level languages. You can interact with the hardware directly using these languages. But with Python, you can interact with the hardware, but it will it is slow, because it has to do a lot of things internally. But in C or in assembly language, you just tell the thing, do this, and it does immediately, because it knows what exactly you want it to do. But in Python, you know it takes time to do it, because it realizes, okay, I have to do this, okay, this is this thing. In C, let me give you a brief overview. In C, you tell, hey, this is a number, hey, this is my name, and this is a unique ID, whatever. But in Python, you don't tell anything. Python automatically decides while it's running that if it's a number, or if it's your name, or if it's a string of letters, whatever. Computer that sorry Python understand while running the program, running your scripts. But in C, you just tell the computer, okay, this is an integer. What is integer? Anything from minus infinity to plus infinity. Okay, it is integer. Okay, so you tell the computer it is integer. Integer doesn't have the decimal form. That is, so let's say 5, number 5 is an integer, but 5.11 is a float. Anything with dot is float. Okay, so let's say in Python, you say this, that 5, and then you write 5.11. Python won't know at first which is integer, which is float, and then you write, my name is Subhodeep Sarkar. It won't know. It's your name, it's a letter, whatever. When it's running, it will get to know, oh, this is an integer. Oh, I see, this is a float. But in C, you have to declare it. And this is where comes statically typed and dynamically typed languages. Since in C, Java, and many languages, you have to already declare. You have to declare what this is going to be. Hey, that's a integer. Hey, that's a float. Hey, that's a name. You have to tell all these in C, Java, all of these. So these are statically typed. What do you mean by statically typed? Statically typed means it won't change. You cannot change an integer later on to float. It will give you an error. Both in C, both in Java. Okay, both in C and Java. It will give you an error. But in Python, hey, this is a number. No, that's not a number. It's a float. You write 5.00 as 5. You write 6.11 as 6. It won't give you an error. But in C, if you do the same thing, it will give you error. Because in C, it's statically typed. You have to tell it first that, hey, it's gonna be an integer. It's gonna be a float. But in Python, you don't tell anything. Python is super intelligent, and it understands while it executes the scripts. Okay, so Python is dynamically typed and C is statically typed. So why is it so? Dynamic type means it can change. Okay, it can change anytime, and the computer does not know which is what. But in statically typed, the computer knows which is what. Okay, computer knows this is an integer. Computer knows this is a float. Computer knows this is a string. But here, computer does not know anything. It only gets to know when it starts the script. Okay, so there we come as statically typed and dynamically typed languages. Dynamic means it can change, static means it cannot change. Now, what is the difference between the human language and computer language, or sorry, programming language? There's not much difference at all, actually. Let's say you are an employee and I'm your super freaky boss. So I'll give you commands. Hey, you must submit this by tomorrow. This is a command I give you. And just like you are an employee, a computer is also an employee to me, or at least you can say a computer is my companion or personal assistant or slave, whatever you want to say. I give you instructions, you follow my instructions, and you give me the expected result. That's what languages do, right? I'm a boss. I tell you to submit the assignment by tomorrow. You do it. You do it. And I tell the computer to add those numbers. The computer adds it and gives me. So what it is? It is following orders or following instructions, or you can say in a better way, executing your commands. In computer language, you can say executing your instructions. Okay. Now let's come to the next topic, compiled languages and interpreted languages. This is a very, very, very important topic. Please listen to it properly, because later on when we actually work in Python, I'll show you uh, how interpreted language is different from a compiled language. I wish I could show it right now, but it would make the video very lengthy, so I don't want it. When I start the class, I'll show you the difference between a compiled and an interpreted language. But still, just let me give you a brief overview. So here's the thing: Python is an interpreted language. Just know this: Python is an interpreted language, and C is a compiled language. Now, what is the difference? Let's say you have a live. Okay, first say what is interpreter and compiler. Okay, let's first understand these. So when you write print hello world, you tell the computer to print hello world to the screen, but the computer even doesn't understand that also. Computer only understands 0 and 1 form. So we are actually writing high level language, and that language is converted back to computer 0 and 1 ultimately. We say print hello world, ultimately it gets converted into 010110100010, some sort of freaky big number. Okay, that's how computers understand the programming language. Even the programming language computer does not understand, but the thing is, computers can decode into its, or you can say translate into its own version, computer understandable format, if you give a computer a programming language. But if you say, hey computer, print this, computer won't be able to translate it. But computers are able to translate or decode programming language into 0 and 1s. So that's how you say, hey computer, print hello world. The computer then somehow converts it into its own machine form and then does it, what you say. So this conversion, that's where compilers and interpreters come into place. Both the things actually do the same thing. Compilers and interpreters are not that different. Both the things ultimately have one goal: to convert programming language into machine understandable form. And what is a machine understandable form? On off, on off, 11010, whatever. That is the thing. But there's a notable difference between both of these. In compiled languages like C or Java, let's say you want to add two numbers, you say, hey user, give me two numbers. First give me one number, okay, next give me another number, you entered that. Now you add it, the computer adds it, and then displays it to the screen. All the codes are written, let's say 5 lines of code: first, second, third, fourth, fifth. What a compiler does is reads all of the line 1 2 3 4 5, understands it, executes it. That's what a compiler does. It reads all the lines together, then converts it into machine language and then executes it. Okay, that's what a compiler does. But interpreters are quite different from compilers. So you tell the computer, ask the user for inputs. So your computer will be like, hey, give me input. You say 2. Okay, you got it. And then the same thing happens. You enter another number, and then the computer adds it, then prints it to the screen. But there is a notable difference. Let's say again in Python or any interpreted language, you have 5 lines of code: 1 2 3 4 5. Now here's the thing: interpreter, if it's an interpreter, it will be like line 1 print, line 2 execute, line 3 execute, line 4 execute, line 5 execute. You see, this is the difference. A compiler is like read 1 2 3 4 5, understand it, execute it. Interpreter, read line 1, execute it, read line 2, execute it, read line 3, execute it, read line 4, execute it, read line 5, execute it. So interpreter reads line by line, and once it reads the line, it immediately executes it. it immediately executes it, whereas compiler reads all the lines together, then understand it, and then executes it. And you will see the difference more when I actually show you how to work with Python interpreter. Actually, in the next session I'll show you. Okay, so let's move on to the next topic. I hope compilers, interpreters, statically typed, dynamically typed, and memory, all of these are clear. Okay. Oh, I have one part left. Okay, tell me more about computer memory. So you have seen these people say, I have 4 gigabytes of RAM in my computer. I have 8 gigabytes of RAM in my computer. So what is this RAM? A computer memory has 3 parts, or you can say, at least 2 parts: primary memory, secondary memory. Now you will ask, why the computer has 2 parts? Why not one? Why not only single primary memory? Why not? So here is the reason why not. Because let's say you are suppose you are playing a game. Okay, you are playing a game. You are a character who has this mission, and you go to complete this mission. And in the meanwhile, while completing the mission, you have not yet completed. Let's say you are completing the mission, and at that point of time, your mom comes to the room shouting, "Why didn't you study?" and switches off the power button. Ouch! It hurts, right? So it's a very bad thing. Okay, I have faced it. Now you turn it back on. You open the game. What do you think? Okay, guess. What do you think that will you continue the mission where you left at? Nope, you won't, because you haven't saved that mission. You haven't saved that mission. Maybe it was there for a certain amount of time, but you haven't actually saved it. Okay, so if you would have saved it, you could have played the next part. But since you haven't saved it, the progress will be lost. The progress will be lost, and you will have to play from the very beginning. And maybe you have also seen this in somewhere else. In Microsoft Word, when you try to close a document without saving it, it will say you that, do you want to save your work? Because if you don't, you will lose your work, right? So if you say yes, it will save the thing to secondary memory, not primary memory. Why not? This is a question, why not? Because primary memory's main function is to keep things temporarily. For example, we are watching a video currently right now. Let's say you are watching my video. Okay, let's say you are watching a cartoon video. Okay, so the cartoon video is stored in your hard drive, and you're playing it. So do you think the computer goes to the hard drive every time asking, hey, give me this part, hey, give me that part? Nope, that's not happening. Because if it happens, or if the computer is programmed that way, your video will run in like this, like slow motion. It will take a lot of time to play the video, because hard drives are very slow as compared to RAM. So you take the computer now knows you will be watching the first half of the movie, or let's say a video. It will transfer the first half of the video from hard drive to RAM, so that your computer can access it very quickly. Because you don't want slow videos, right? You want a video like smooth. Okay, smooth. So for that to work, your computer will take the things that you will watch, take it from the hard drive, put it in the main memory, which is RAM, so that you can access it fast. So you have watched the complete video. Now you close the video. Okay, you just close the video. The things that the computer took from the hard drive into the RAM are thrown away, are simply thrown away. Because maybe you will see some other video, maybe you will see some maybe you will read some books, maybe you may do some other things which will take memory. That's why it is removed. So the basic difference between a RAM and a secondary memory is, a RAM keeps temporary data. Once you switch off your computer, it goes away. Shoo, like a magic, it goes away. Okay, it is not saved. That's why for saving things you need the secondary memory, which is the hard drive, or you may say nowadays SSDs are very popular, or you may say pen drive. All of these are secondary memory, and these are pretty slow for obvious reasons. A hard drive has to rotate like this. It has a needle which goes like this, and points it to the location that you want to see. So this is why hard disks are slower as compared to RAM. Okay. So these are the two sections of memory. Now let's move on to the next section. So the next section is why Python? This is a very interesting question. Why Python? You could have chosen C, you could have chosen Java. Now obviously Python has its own disadvantages, its own advantages as well. So why Python? Why you will choose Python? Let's say you have a very big project, that you will have to complete. If you choose C or let's say Java, it will take a lot of time. If you choose C or C++ maybe, it will take lots and lots of time. For example, it may take 1 month or 2 months maybe. Or if you take Java, it may take I mean at least less time than C, but still notably longer time. Let's say it will take 3 weeks. But if you take Python, it will you can just finish it within a week. Because Python is very simple. Python is intelligent. Python knows how to deal with things that C and Java or those languages do not know. In Python, you don't have to say everything to the computer. You don't have to tell the computer. Let's say you want the computer to, let's say what? Okay, let me think of an example. Okay, let's say you want to multiply two numbers, then put it in somewhere in a memory, and then print it to the screen. You only have to tell that, hey, take two numbers, add it, and print it. You don't have to worry about how the computer keeps the things in the memory, how the computer accesses the things from the memory and then prints to the screen. You don't have to think about all of this. But in C, at least in C, you will have to understand all of this. You'll have to understand how computer manages its memory. You'll have to understand how to access a particular location of a memory. These are the things that you have to understand. It is very complicated, trust me guys. And that's why Python comes into place. Python is simple, very easy to learn and very easy to implement as well. Okay, but what are the disadvantages? First, it is interpreted languages. So what's the difference? What difference does it make? Compilers can read all the thing at one go, then understand it and then execute it. But in interpreter, as I told you earlier, read one line, execute it. Read one line, execute it. This makes the computer slow. This makes the process slow. This way your code will execute in a slower manner as compared to a compiled language. And also it is a dynamically typed language. So that means you won't tell the computer, hey, it's this, it's that. The computer will automatically, understand what it is. But in order to understand it will take some time, because computer isn't just, okay, so this is an integer, I know this. Computer cannot know everything from the very beginning, because you haven't told the computer. Computer runs your program, understands it, that okay, this is an integer, this is a float, this is a name, this is a string, this is the email ID, and then processes, and then output is seen on the screen. So this is why it is slow. But whereas C or Java, there it is already written that it is this, it is a name, it is going to be an integer, it is going to be a float. The computer knows. The computer doesn't have to spend time in order to understand what are these. That's why compiled languages and statically typed languages are faster as compared to dynamically typed and interpreted languages. And also Python has thousand different fields, okay, hundreds different fields. Python has AI, Python has data science, Python has machine learning, Python has web development. In fact, let me tell you this thing, If you ever learn web development through Python using Django, it you will be able to create web applications much faster than other languages like Node.js or JavaScript. JavaScript's backend version is Node.js or some other languages. Okay, because Django is made out of Python, and that makes lives easier. And what are the other domains? Automation, which I'll be going to teach you, data mining, and all those other stuff. Python has lots of different fields where you can go. Image manipulation, AI, all these stuffs. In fact, IoT is very important. And there's a thing called Raspberry Pi. It's basically a machine, let's say, which you can use to build robots or a car or automated car, something like that. It's very advanced thing. So there are these fields of Pythons. I know it feels interesting, and it is. Okay, it is. So how Python will make lives easier? Let me give you a brief example. Let's say you have two numbers in two places. Okay, so let's say here is A and here is B. It is 1000, it is 100. So let's say I give you a task to swap these. I mean, here is 1000. Now you will have to take this 1000 here, and here is 100, and you will have to take this here. Okay, now by using languages like C, you will have to write near about 10 lines of code. Okay, but in Python you will just write, let's say this is A and this is B. You will write A comma B equals to B comma A. Finished. It's done. That's easy. That's how easy it is to work in Python. Python is extremely good. Okay, extremely user friendly, or you can say programmer friendly. Okay, it's very easy to use, very easy to learn, and it you don't have to reinvent the wheel. Let's say you don't have to make everything from the scratch. Okay, it's already there, just use it. Someone else has written it, just take it and use it. Let's say you want to connect to a database. Okay, you want to connect to a database, so you don't have to write codes from scratch. You don't have to mention the computer, hey, go through the network there, access the database, this that. You don't have to tell all of these. Maybe someone has written something, some lines of code, just take it, use it. You don't have to write your own code to and waste your time. Okay, so Python enables us not to waste time. Python, you will love Python once you start doing work with Python. You will see how much time Python can save. If you're coming from another language like C or C++, then you will definitely understand this. Okay, so that's how Python makes our lives easier. Okay, I guess that's it for today. And in the next video, I'll show you how to set up your own developer environment, how to install Python locally, how to install tools that you will use in the class to work with Python in the next class. Okay, and someone was telling me in the group to send 2 videos a day, so I'll try to do it. But I have one question: can you guys take all of that stuff in one day? Because people have different times, that is the thing. So everyone may not be present at the time I post a video. So this is the reason I actually send 1 video a day. And tell me in the group if you want it or not. Okay, I'll then see what I can do, because I have all the other things, and I'm actually preparing for entrance exam for my masters. So that's why I'm little busy these days. But don't worry, I'll try my level best to provide you assistance. And if you have any doubts regarding this lecture, please contact me. Okay, I'll help you. I'll definitely help you. Okay, see you guys in the next video. Namaste. Bye.